Welcome to the 3D Printing Screencast number 1. In this screencast, I'm going to be showing you how to use a slicing software called CURA that we'll use to translate information from SOLIDWORKS into a format that can be 3D printed. And just to start off, if you take a look at this slide, here's kind of the overall 3D printing process as I'd summarize it. First, you got to start off with some sort of idea. Then you have to make that idea into a three-dimensional part in a CAD software like SOLIDWORKS. And I'm going to skip a step here, moving over to 3D printing. Before you can 3D print, there's a process that you go through called slicing. And we'll be using a slicing software, here's step 3, called CURA, that basically tells the 3D printer what settings to use while it's printing it. Then after you 3D print it, there's actually, I should have another little box here that says usually there's some sort of finishing that you'll need to do to the part. It doesn't usually come out just like you want. You might have to do some sanding or other things, like there's some chemicals you can use to finish the part. And then you put it in your application, maybe some sort of a robot. Okay, so we're going to start off by going to SOLIDWORKS. And I'm opening up the part file that we created in one of the SOLIDWORKS tutorials, a bolt. And the first step is saving this part as what's called an STL file. So like Sam, Tommy, Lauren. So we're going to go up to the Save button and click Save As. And instead of a part, we're going to go up and select STL. And I have already done this once, so it's already there, but you won't have. So click Save, and you'll just take a look at this. This is what SOLIDWORKS and other CAD softwares will save it as. Basically, it's taking your three-dimensional part and breaking it down into a bunch of points and lines and triangles, the lines that go in between those points. So it's a way of simplifying the part so it can be imported into the slicing software. Okay, I'm going to click Yes on this. The STL file, by the way, stands for stereolithography, and that's a word for like breaking a 3D part like this into a bunch of points and lines. Okay, once we've done that, we're done in SOLIDWORKS, so I'm going to close that one out. Get out of my PowerPoint here. The next thing we're going to do is open up a slicing software called CURA, C-U-R-A. This one's not on the desktop, so I'm going to go into the Windows button. I'm going to type in CURA, and there it is, CURA version 15. And we're letting it load here. All right, so this is our first time running it. I'd like it to speak English. Select your machine. We don't have any of these specific machines, so we're going to select Other, which means we're going to set up some custom settings for it. And so for other machine information, also select Custom. And then here we go. The 3D printers that we have are called the Airwolf HD, so A-I-R Wolf HD. And once you type in these settings once, I believe that the settings will be saved for you anytime that you log on to that specific computer. So you should only have to do this part of the process once. Machine width in millimeters, it's 280 millimeters, so 28 centimeters. The machine depth is 200 millimeters. The height is 300 millimeters, so 30 centimeters. The nozzle size is 0.5 millimeters, and it is a heated bed. But the bed center is not at 0, 0. In this case, the bottom left corner is 0, 0. So don't select that last box. Then click Finish. I'm not going to download the new version because I can't install it right now. Okay, and here we go. So I'm going to just use the scroll bar, or the scroll wheel on my mouse to move around a little bit. This is showing the size of the bed on the 3D printer, and it's got this little robot thing in here. You can even move it around if you'd like, just as an example of a part that you could 3D print. Okay, so we're first going to go through and change a few of our settings for 3D printing. And so if you look on the left, there's all these tabs: Basic, Advanced, Plugins, Start and End, G-code. We're going to go through the basic settings, and I'm going to tell you what to type in for the different settings. And this is based on the material that we're printing with, which is called ABS plastic. So here we go. We're going to start off with the layer height. The layer height is going to be 0.18 millimeters. And you'll notice as you're highlighting over these, or if you're hovering over these, that there's a little description of what this means. I'm going to tell you about a few of the more important ones. Layer height, if you make this number smaller and smaller, it will make the print finer, so it'll make each layer smaller. But it also means it'll take more time to print. So 0.18 is going to be great for what we're doing. If you find that the part isn't as fine as you'd like, especially if there end up being holes in your part where it's it has to print at an angle, that's something you can do to if you decrease that, that's something you can do to make that better. The shell thickness, we're going to go to 0.5. The shell means that when we're printing or 3D printing something, it's not actually going to make this robot into a solid part. It's actually going to print the bottom, and then the inside is going to be hollow. The shell thickness is basically telling it how thick does it want to make the shell, or the outside part of the part. And this is something you might also want to play around with if you're having trouble printing your first time. If the part is warping as it cools, you can sometimes fix that by increasing the shell thickness. Okay, enable retraction. Let's leave that box as clicked. Our 3D printer will retract the plastic out of the print head as when it's not in the process of printing, so that more plastic doesn't drip out. Okay, fill, the bottom and top thickness, which is how thick the bottom and top layers are, and the bottom layer especially is quite important because that's getting stuff to stick on the bed is kind of sets up the whole print, and we're going to put that at 0.8 millimeters. Fill density, we're going to type this in as 25. And like I was saying, when you 3D print a part, you're not going to be printing it out with 100% thickness. You're going to print the parts hollow. And part of that is to save time, but also to save material. And so for this particular part, for most of our parts, it will make 20 or 25% density is going to be great. We might even go less for a lot of parts if it doesn't need to be particularly strong. Okay, speed and temperature, these settings, I'm going to tell you and not describe too much. It's just for our machine. 25 millimeters per second for the print speed. 240 is the temperature of the actual extruder that's putting out the ABS plastic. And then the bed itself is also heated, and it's going to be 115 degrees. And the heated bed makes the plastic stick onto it better. All right, in this case, we're not going to add any types of support or adhesion types. The diameter of our filament is 2.85 millimeters, and the flow percent, we're going to do 100%. I'm going to click over to the advanced settings, and these we're actually just going to leave it just as it is right now, but these are also things that if it's having trouble printing, if you're having trouble with the print going, you might change some of these. But for the most part, the basic settings are the things that we would need to print. Okay, so we just did the settings. So those should be saved in here right now. I'm going to get rid of this little robot by just clicking on it and pressing delete on the keyboard, and then I'm going to load my own part. So click the load button in the top left here. I'm going to go and find the part that we had created and then saved as an STL file. That's the type of file that it needs. Here we go. Bolt, and it's an STL file. Click open. Okay, so when you load it, the CURA, the slicing software, puts it somewhere, in the middle of the bed. You can click and drag to move it around. But really what's important here is to figure out what orientation do you want this part to be so that it'll print. And as it is right now, you can just think about the way this would print. This really wouldn't work. If you look at the head of the bolt, there's only one small part that's touching the bed. The rest of this plastic, this is too steep of an angle for the plastic to build on itself. And then the cylinder of the bolt is just floating above the bed. So this clearly won't work. I'm going to click on it and click the rotate button, and I have these little circles that I can click on to use to rotate it. So I'm going to show you one orientation. Oh, sorry, not that one. Let's go like, nope, not that one. Sorry about that. Okay, how about this one? And we're going to rotate it 90 degrees this way, and you'll notice it automatically makes it touch the bottom of the bed, which is good. This would be a possible printing configuration, but this would also have the same problems or similar problems. It would print the bottom cylinder just fine and keep printing up here just fine. But then when it gets to the head of the bolt, there's a big overhang here at a 90-degree angle, and this plastic wouldn't have anything to be supported by. So that print wouldn't work. So here's the solution that I'm going to suggest, is rotating it 180 degrees the other way, or 90 degrees from our original configuration, and this should work. So right now it'll be able to print the bottom of that hex shape. It'll print that first. It'll print the top of it with the hex shape with the shell, and it'll be able to print the cylinder on top of that. Okay, zooming out a little bit just so you can, I'm going to get rid of the rotate feature. You can move this around wherever you'd like on the bed. In this case, it really doesn't matter. But if you were to, you can load multiple parts in here at a time. And actually, I'll just show you how to do that. You can right-click on the part and multiply the object. Let's say we want 3 more copies. You can move these around the bed, and you might, think about how you want to space them so that they will print well and they'll fit. So I'm going to get rid of those. Click on them and delete. But you can do multiple of the same part and also multiples of add additional parts that are different from that. Okay, so we're basically set here. One thing I'll just point out is that as we make changes to this, the print time is loaded or is stated right here. So it keeps kind of thinking through and checking how much time it'll take. Good. Let me show you this view too also for just a second. If we click on the view mode at the top and select layers, you can see it'll actually give you an option of seeing what the layers of this part will look like. Oh, here we go. So as we grab that scroll bar, you can see right now if I zoom in. You can see the shell that's in red, that's solid, and then this is the fill. This is what 25% fill density would look like. And just to show you what that would look like if we changed it, let's say we went to a fill density of just 10%. It's going to rebuild this model. There we go. So 10% is pretty small. There's not very much in there. And the print time goes down to 37 minutes. If we added fill density of, let's say, 50%, it's going to rebuild the model, take a minute to think about it, and that's what 50% would look like. Okay, let's go back to 25. Okay, I'm going to go back to the normal view mode. All right, we're almost done here. Now that we've set all the print settings, decided the orientation and where it needs to be for printing, we just need to save it as a file type that's called a gcode, which is also called machine code. So File, and we're going to save gcode, and we'll save this somewhere into our W drive. This is the actual file type that the 3D printer works on. It is also, the gcode is also the file type that most of our other machines or most other automated machines like this work on. So CNC machines, for example, like our CNC plasma cutter and our CNC laser cutter, can also work on gcode. All right, that is it for the tutorial. Thank you very much for watching the 3D Printing Screencast #1.